Dear students, welcome to my lecture. So today we'll go for the B plus tree insertion and deletion. In the last class we have learned about the B plus tree. So today we'll go the further more some example. So in the insertion in the B plus tree, you have already informed that there are two levels. One is the leaf node or the data node, and another level is the markup or the insertion level. From the B plus tree, you have already know that all the data nodes are persist in the same level, whereas the markup node is the higher level from the data level, which is basically show the direction where we will get the data. So if you already have a tree, suppose here inserting a value into B plus tree may unbalance the tree, so rearrange the tree if needed. So all the times the tree are not looking like the same, so you have to understand, or you have to rearrange the tree among the different ways. So in here one tree is already created, so here the tree is already created. Here the m equals to 5. So as m equals to 5 here, so if we write this thing, that is the branching factor m equals to 5 here. So as m equals to 5, so number of keys can be how many? So it is 5 minus 1 equals to 4. So each of the node may have maximum number of 4 values. So now see, the thing is there may be 5 branch can be possible. Among them you can keep only 4 values here. So there are some leaf here, that is 25, and from among the 25 it having another algorithm following another algorithm. This algorithm shows that you in the left of the markup you can keeping the values of its equal or is less, and in the right side you can preserve the value of its higher or equal. So it depends on algorithm of different algorithms. Now if we insert 28 here, so if we want to insert 28 here, we will first appear the values from the scale of here. We will come the values with 28 here. So whenever we choosing 28, then we show the path. We will go in the right side of 25 because 28 is greater than 25, right? So, and less than 50. So we'll choose these block of memory. This is all the data. This is the data leaf node. It is the markup level node. So data will be preserved in the leaf node. So now we see that if we want to insert 28, so there are enough space here. After 25 and 30 there are 2 space, but whenever we insert some values, it should be in the sorting order. So 28 will be inserted in between 25 and 30. So we have to make a right shift of the value 30, so the data will be shifted from here, and one blank value will be a blank key field will be appear here, and we will insert 28 here. So that is the basically rules. So 25, 28 and 30, and one blank space will be created. So 30 will be shifted from the second place to the third place, and in the second place the 28 will be inserted. So this is the a scenario which is fits in the leaf. So the result node will be like this. So it is 25, 28 and 30 in the leaf node. So it is set already in the leaf node, and the markup need not any change because there is no value inserted from the below part of the data leaf which can impacted the markup level. So that is one thing. Okay, so another example, we want to show that in this same tree we want to insert a value 70. So if we want to insert a value 70, then it is greater than 50 and less than 75. So it should become where? It should become the left of 75. So left of 75 and right of 50. So it will need to persist in this node. But there is no place here. All the 4 places are occupied. Then what we need to do? So we have to do something which can be fit. So what we will basically do, so if we want to make 70 here, so there will be 5 keys, but the maximum number of keys here is 4, so it will not fit here. So we'll just split the node into 2 parts. So as it is, if we split the node into the 2 parts, so what will happening here? This 50, 55, 60, 65 and 75 values are already here. So what will be the median value? 60. So 60 will be split up and promote, as the rule is of the B tree. So 60 will be promoted here, but see that it is already 75 is in the 3rd place, but 60 is less than 75. So 75 will be right shift. So there is a small arrow is showing here. So 75 will be shifted in the right space here and 60 will be placed in here. But as the 60 is also a data, so 60 will be persist in the data level also. So the basically things is happening here. So 25, 50, 60 and 75. So 25 node, all the data are same. The 50 node, 28 is inserted in previously. There is 3 level of data, and after 50 and in the left of 60 there is only 2 data, but we have to create the 4 blocks. Why? Because there are maximum 4 number of keys, because m equals always m is equals to 5 here, so key is equals to 4. So 4 blocks are need to be created in the same level. Show that it's in the same level. You cannot make it up and down. Whenever you draw this tree, you can make your script in the landscape mode if it is not adjustable in the portrait mode. So but it should be in the same level. You have to maintain it. Okay, so after the 60, the greater equal 60 or greater 60 are in another node. There are 3 values are fitted here. So 60, 65 and 70 is here. So 3 values is here and 1 blank is also persist here, and after 75 the values are remain same. So that is the policy of insertion of the value in the B plus tree. So now if we see another thing is the 95, we want to insert 95. So what will happening here? So as 95 we want to insert here, show one thing. So 95 will be after the 90, so there is no space in this node, right? There is no space in this node because the 4 values is already occupied. So we have to key the value in up. So key value will be up in the promoted, will be in the promoted in the markup level. So if we consider this markup level here, that is 20, 25, 50, 60 and 75 is already here. So if we up one markup 85, because 85 is the median among these 5 here, so there is no space for 85 here. Okay, because 85 is the 5th value for this markup level, but in the markup level there are only 4 keys can be persist. So these values are splitted again. So this value is splitted here, exactly here, okay, because 85 will be gone up. As the 85 is gone up, so left of 85 is below than 85. So 75 and 80 will be the left side of the this node, and in the right side, 85, 90 and 95 will be in the right side of 85, but the node which is the markup, it need to be split also, because it cannot have 5 values because there is a maximum limit of 4. So what will be the thing here? So that is the thing. So 25, 50 and 75, 85, these are the markup level, these are the markups. Okay, so these are the markups and this is another markup. So markup can be hierarchical, but from there you have to put all the datas are in the same level, So see that all the datas need to be drawn in the same level as I mentioned early. But if there is no available space, so what we can do, we can just make the arrow some little lower of its level and show it is properly, but you have to draw the 4 blocks. It should be mandatory, it cannot be considered. You cannot draw only 2 blocks if it is contain 2 datas, so you have to draw the 4 blocks, but there can be 2 datas. If there is no available space, you can draw some little down, but we will consider it as a markup leaf. So that is the thing, we can do it. So 60 will be the index page, or 60 will be the indexing node, middle key of this tree, where the markup from the left is the left of 60 and from the right it is higher than 60, and from there the root node is again splitted. So the values are totally rearranged again in the tree. So now we will do some delete operation here. If we want to delete 70 from here, so the value is 70 is here, right? So 70 is already here. So now you have to see one thing is, you have to remember one thing is, that is whenever you want to delete some value from the data node, you have to keep following that this value is also in the markup level or not. If it is also in the markup, then you have to change the markup level too. But if it is not in the markup, you are just deleting the value from the node. But one thing you have to remember, that the place should be following the rules of the maximum or the minimum value range. That is the you have to, if the value of m equals to 5, so the minimum value, what will be the minimum value? The minimum value will be m minus 1 divided by 2, and it is a ceiling, so it is 4 by 2 ceiling, so it is 2. So 2 value at least will be in the node whenever it is deleted. If there is less than 50% or less than the minimum value, then you need to be merge the value with the adjacent node or adjacent data node if there is available space. But if there is no available space in the adjacent node, but you are having only one data in the data node, you have to keep remain same, because you cannot push another data where there is no space. So if we want to delete 70, so it is very simple, as 70 is not persist in any of the markup level, so you were just simply deleted the 70. This value will be the blank and the tree will be like this as a result. So if we want to delete 25, so 25 is also in the indexing or in the markup. So as 25 is already in the markup, so what will happen here? So 25 is in the markup, so 25 is deleted from here, so it will be blank. So you will make to shift 28 in the left and 30 another left, that is that these two values are in the left shift, so that is okay. So you can make that is a very similar form of very in any form that you like. But one thing is, the 25 is also persist in the markup level. So as 25 is already persist in the markup level, if you delete it from the data level, so it will be also deleted. So if it is deleted, then which value will represent here to direct the left and right? So that is the question. So what we have to do is, we have to took a value from the previous level. So we have to represent some value from the previous level, which is very small value, which is persist in the most left of this node. So 25 will be replaced by 28, and if we replace the 28 here, then it is on the right side of 28 and 30. So it will contain the equal or the higher value of this node, and the other values which are left of 28 will be lesser than 28. So it is maintaining the rule. So if we replace the value 25 with the 28 here, so the left of 28, it will be lesser values of here, and the right of 28, that is the higher value or equal value of 28 in the data node, and other part of the tree are remain same. So there is no change is required. So if we want to delete the 60, so if we want to delete the 60, so 60 in the data node, you already see it, 60 in the data node. So if we delete the values from here, so what will happening here? The 60 is deleted from here, and 60 also persist here. So 2's value will be deleted. But whenever we delete 60, it having only one value, that is the 65. So 65 if having here, so if as it is a m equals to 5 tree, so it must have a minimum value of 2 values. So whenever it is lower than 2 or less than 50% is full, so we need to be merged with the adjacent left. So whenever we want to merge it with the adjacent left, the left node need to be free, at least the space. If it is occupied, if there are 4 values 50, 55, 57 or 59, then we cannot merge it because it is already full. But if it is not full, it is already have the space, then we have to merge it. We can have to merge it. So the node will be 50, 55 and 65 in the node here, and 60 will be deleted here. As the 60 will be deleted from here, so these node also can be merged, because there is no needed of these nodes. So as this node is not belongs here, so there are only 4 values 28, 50, 75 and 85. So these 4 values can be persist in a same level. So and also these node is also merged, so there is no problem happen. So the resulting tree will be like this: 28, 50, 75 and 85 in the same level, whereas the 50, 55 and 65 are merged, and the 60 is already deleted from the index level or the markup level, and all the datas are now preserving in the same level. This is how the total tree is managed. So if you have a example of these, the last class we have a practice example. This is the answer of this practice example of that. So you can practice it from there. So thank you for watching this video.